Welcome back to another Doll 366 Replica episode. Today I want to get the eccentric works running, just to make sure that everything in here is alright and that when I turn the eccentric shaft, then the piston will actually be moving back and forth. We'll start by making the two bearing blocks. They're identical and I'll probably make them out of three pieces, one for the bottom mount, one for the pillar and one for the bearing. Well, I've test mounted everything up and it looks rather nice. However, I must have made an error somewhere because the way this is rigged up, the eccentric doesn't even allow for more than half a turn before the end of travel of the valve rod is reached. So I can turn it from here to here, and that's how far it will go. Now, I don't need the additional amount of travel because somewhere down here is already the position where the valve switches between letting steam in and feeding it out. So I reckon somewhere down the line I might have made an error calculating the amount of eccentricity needed to properly drive the valve rod in its respective two positions. In other words, I'm going to have to find out what the proper amount of eccentricity is and then remake the eccentrics. Attempt 2 with 6 millimeters of eccentricity this time instead of 9. Alright, everything back together again, and now when I put some air on here and twist this around, and maybe you'll see in the back that the piston is indeed moving back and forth. Now, call me insane, but I do want to try and make the bevel gears for the valve train myself. If all else fails, then I can always buy one. But for now, I just wanted to try things out. So here's how that's going to go. Now, the dividing head which I have does not have a degree scale on it. So with the whole disc that I do have and the scriber, I made myself something of a degree scale. And that should be, accurate enough for my purposes. For the bevel gears, I've borrowed me one of these gear cutters. Now, I'm more lucky than I can comprehend because this is my standard shaper tool holder. And look what is a perfect fit. I just need to put the nut on here and crank it in the shaper. No problem whatsoever. So I've made a test piece out of plastic. Doesn't look like much, the camera probably isn't able to pick it up, but it looks like a gear to me, so I think I can continue with the proper thing. I've made me a piece of brass here, which has the needed contours, and set up the gear cutter on center height, if you will. Zeroed it out, 0 on the scale. And now I've got a list which I'm going to work. Ideally, you would always hob a gear like this. However, you can approximate the whole thing by doing 3 passes per gear tooth. First pass is on center height, and then the second one is to the left of center, and the third one is to the right, with a couple of degrees offset in between. And what you're doing by that is rounding out the root of the tooth to the involute gear profile, because when you're doing an angle like this, then the tooth is going to be thicker at the end than it is in the middle. And since we can't hob it exactly, we are going to approximate it, as I said. Well, it looks a lot like a bevel gear to the naked eye. So now I'm going to make the second one in exactly the same manner, with a little bit smaller of a bore. Crankshaft big, camshaft small, and we'll see how they mesh. While I'm waiting on that to arrive, I'm just going to make a couple of other miscellaneous parts to get this project forward.
Little Joe from Chicago wears a big blue diamond ring. Little Joe from Chicago never wants for anything. He handles plenty money and he dresses up like a king. Little Joe from Chicago never spent a day in school. Little Joe from Chicago never learned a grammar rule. But how he handles money makes you know he's nobody's fool.